Hi everyone, my name is Joe and today I'll be teaching you about machine learning. But before we get into a hands-on demonstration, I'll first walk you through a quick introduction about machine learning. Machine learning is a smaller field of artificial intelligence. It is based on the idea that machines are capable of learning from past experiences or previous data supplied to it, and make the necessary actions based on those data. Machine learning can be divided into three different types. You have supervised learning, unsupervised learning, and reinforcement learning. Today we'll be focusing on supervised learning. Supervised learning is a type of learning where the input and the output are given, with the goal of figuring out how those two are connected. Supervised learning can be broken down into two types. We have classification and regression. Classification deals with classes, and regression deals with numerical value. The one that I'll be doing or demonstrating is the regression. We'll be predicting the prices of houses based on the properties of those houses. So let's go. Now here in our online compiler, I'm going to show you how to use machine learning to predict the price of a house using the decision tree regressor model. As for the dataset, I will be using the Melbourne house dataset. The first thing that we need to do is to find a compiler to run the code. Here I'll be using an online compiler. The next thing that we need to do is to create a data frame or tabular view for our data. To do this, we will need to import the pandas library. So import pandas as pd. Okay. Now that we have imported our library, we now need to load our dataset. This right here. But before that, we need to know the path or location where our dataset is located. I'll first make a variable to hold the path of the dataset. I'm gonna call it path. Then it will hold the location of our dataset. To make it easy, I'm just gonna copy it right here, copy the path, and then Control V, and there you go. Now that I have the path, I will now create a data frame and place it inside a variable. I'll name the data frame house data, house_data is equal to. Then I'll be using a built-in function from the pandas to load my dataset, which is pd.read_csv. Okay, CSV. And I'm gonna pass it the argument path. Right there. If you run that, hopefully there are no errors, and okay, it's great. Now we have our data frame. To get a better look at our data frame, we will need to look at its columns. These columns are what we are going to use as our target variable as well as our feature variables. We can view the columns using this line of code. First, the name of the data frame, house_data, dot, and the keyword columns. If you run that, we will, let's see, oh, there you go. We'll get a list of columns from our dataset. We can see a lot of columns, but we'll only be using a few of this. Since we want to predict the price, we'll be using price as our target variable. And we will be using a few of these columns as our feature variables. Okay, next. To avoid dealing with missing values, we need to drop those missing values. We can do that by using this line of code. First, the name of the data frame, house_data, there you go, is equal to house_data dot drop na, and then argument of axis is equal to 0. Basically, it drops all the empty rows and columns. And there you go. It'll make things a lot easier now. Okay. Now that we have dropped missing values, it is now time to select our target variable. We present our target variable with the letter Y. Using the dot notation, we select the price as our target variable from our data frame. So the name for our data frame, house underscore data dot price, PRC. Okay, oh wait, price, there you go. The next thing we need to do is select our features. To make things easier, I'm gonna first make a list of the features that I want. First is the rooms. By the way, these features are what the model is going to use to predict the data, or I mean the price of the house. Okay, next is the bathroom. Bathroom. The next is the land size. Next is latitude. Spell latitude, double C-I-T. Okay. Then the next and final one is the longitude. Okay. Now we are going to make our feature variables, and we represent this with the capital letter X. So house underscore data, and we pass a parameter or an argument features. We pass features to it. So we're basically filtering out the columns that we want and putting them in the variable X. I already selected the columns that I want for my features beforehand. There's a rule you should follow when selecting features, but I'm not going to get to that in this video. So let's run this, and longitude. Oh, it's longitude. Really? It's longitude. That's okay, and of course nothing happens because we didn't do anything yet. We just created it, we didn't call it. To view our feature variables, we use the head command to filter out only a few number of rows, specifically 5 rows, so that we don't get a lot of data. So if I do that and run it, x.10, it's taking a bit longer than usual. Why? Oh, there you go. So these are the features: the rooms, bathroom, land size, latitude, and longitude. As you can see, there is no price here because our price is separate. It's located in the Y. So if I type Y head there and run it, it will show us 5, since 1, 2, 3, 4, 5 houses. Then I'm gonna get 5 prices. There you go. Price first house, second house, third house, and so on. Okay, we got that clear. Now let's just delete this and keep that in there. So now let's move on to the next step. Now that we have our data, we can now proceed to training and testing them. To do this, we first need to import the sklearn library, then import train test split. So we first, from the sklearn, wait, I'm gonna check the code for a second, I forgot. Here you go. Model underscore selection. We need to import the train test split function. Okay. Using the train test split function found in the sklearn library, we will split our data into train data and test data. So first, let's make our train data. Train underscore capital X and val X. The X is always capital. and y is small letter. Now train underscore y and val underscore y is equal to the train test split function. There you go, function, and we pass it an argument of our features and our target, and also another argument, and this is the random state is equal to 1. Basically what the random state argument does is that every time when we run our data system, it doesn't give us a set of random houses. It gives us the exact same houses that we had in the first instance, because it would be annoying if we wanted to predict and compare the values if the data are different. So to avoid that, we add this argument random state 1. Okay, now that we have trained our data, we can now make our model. The one that I will be using is a decision tree regressor model. A model is basically the thing that analyzes the pattern in our data and make predictions out of it. But before we can make our model, let's first import the necessary libraries. From a sklearn dot tree, because this is a decision tree, import decision tree regressor. There you go. Regressor mean. Okay, now that we have imported it, let's make our model. I'm gonna name my model, to make things simple, model is equal to decision tree. There you go, decision tree regressor, and pass it the parameter of random state is equal to 1. Basically, I just don't want any random values. Now that we have created our model, let's now put it to work. To make our model analyze pattern in the data, we first need to fit the data, which basically make the model find patterns on the data. To fit the data, we first need the name of our model dot, very simple, fit, and inside the fit function we pass the argument train, or we actually pass our train data, train x and train y underscore y. Okay, now that we have fitted our data, or now the model has analyzed the pattern in the data, now it can predict. Okay, let's label this to make it more understandable. Fit, this is gonna be train, and of course the beautiful part, predict, which is what we want. Okay, now to make a prediction, or so that we can easily compare our prediction with the actual value, I'm gonna put the prediction inside a variable and call it prediction is equal to first the name of our model, which is model dot predict, and then the val x and that z dot head. So remember what I said earlier, the head method basically gives us, it filters out the column, I mean the number of rows that it gives us. It gives us 5 rows. Okay, that's basically our prediction. Now to actually see this, to get a better look at this, let's print it. First, let's print. Okay, I'm gonna call it, this is a predicted price. And then we call prediction. Okay, if we run that, There you go. These are the predicted price. But as you can see, we don't know what to do with this data because we don't know the actual price. So let's solve that, shall we? First we print, I'm gonna call this actual price. Okay, and then I'm gonna use this val instead of x, y, because it contains our prices. Dot head again to filter out the number of rows it gives us. And we want to convert it to a list so that it will be easier to see. And dun dun dun. There you go. As you notice, our model was not able to get the exact price of the houses. See? But considering that the prices of the house is actually in between hundreds of thousands of probably dollars, I say our model actually did well. It was able to pinpoint the exact amount on its first try, but it was close. The model analyzed the pattern in the data and made this prediction, which is actually pretty close to the actual price. If supplied with a better data, the accuracy of the model will actually increase and will make better predictions based on that data. And that's it for this tutorial. Hope you guys learned something. Be sure to leave a comment, like, and subscribe. Goodbye.